Blue Origin joins the race for Mars contracts. This Chinese company is preparing for the debut of its own reusable Methalox rocket. US President Donald Trump directs the government to streamline launch regulations again. And did the James Webb Space Telescope just discover James Cameron's Pandora? Stay tuned for all that and more, coming up this week in Spaceflight. We start off this week in China, where a number of commercial launch providers are preparing their new vehicles for maiden launches before the end of the year. Landspace has completed engine testing of its stainless steel JWST-3 rocket at the Zhochuan Satellite Launch Center. The company conducted a 40-second static fire of the vehicle's first stage in June, testing the 9 Tianque-12A engines, which burn liquid methane and oxygen. 4 of these same engines already power the company's JWST-2E, which unfortunately seems to have had a launch failure on its most recent launch. Stay tuned for the space traffic report later in the video. Producing a thrust of about 815 kilonewtons, these engines perform just a fraction lower than the Merlin 1D engines on SpaceX's Falcon 9. The tests also verified engine gimbaling and control systems, as well as the vehicle structure, avionics systems, tank pressurization, and the propellant loading process. The JWST-3 will eventually measure just under 77 meters tall and 4.5 meters in diameter. That's larger than a Falcon 9, but a little narrower than China's Chang Zheng 5 or rockets such as the Terran R, Ariane 6, or Vulcan Centaur. Initially, however, it'll fly in a shorter and less capable configuration, about 10 meters shorter, at about 66 meters tall. Landspace has said that it's planning 3 flights of this new vehicle before the end of the year, and up to 12 next year if all goes well, which would include the first propulsive landing and recovery of a booster. Now, you might recall the company successfully tested vertical takeoff, engine reignition, and landings of its Hopper demonstrator in January and September of last year. Later versions of the rocket would feature the further enhanced Tianque-12B engines, which have significantly higher thrust at around 1,000 kilonewtons. This is comparable to Relativity Space's 3D printed Eon R engine, and under half of that of the Raptor 2 or Blue Origin's BE-4. With the static fire completed, we're waiting on signs that Landspace is ready for JWST-3 to take its maiden flight in the coming weeks. Landspace was also one of 3 commercial Chinese providers chosen this week by operator SpaceSail to launch batches of its Qianfan internet satellites for their mega constellation, no doubt with the JWST-3. The other winning providers were Space Pioneer with its Tianlong 3 and CastSpace, which would most likely use its forthcoming Kinetica 2. China is one step closer to its ambition of landing its own astronauts on the moon before the end of the decade. A short subscale first stage for the Changzheng 10 has been seen on a stand at the Wenchang Space Launch Site, where a dedicated pad, LC-3, is currently under construction. This subscale first stage was used to test, for the first time, the operation of the 7 YF-100K engines that'll power each of the rocket's boosters. The aim is to validate this operation before moving on to production of full-length boosters for qualification and flight. A similar test article, equipped with just 3 YF-100K engines, was already tested and validated back in June of last year. 7 of these engines will power a central core and 2 side boosters, but stand limitations at the time restricted this test to 3 engines. Testing of these engines first began in 2023 after having been redesigned as an upgraded version of the same engines that are used for the Changzheng 5 side boosters. The 3-core first stage of the Changzheng 10 will deliver over 26 meganewtons of thrust. This is around 15% more than Falcon Heavy and a little under 70% of NASA's SLS Block 1. This amount of thrust will be needed to loft China's Mengzhou crewed capsule and Lanya lunar lander to the moon, which it plans to do by the end of the decade. The first mission is due to launch around 2027. Ahead of this, a single-core Changzheng 10A version will service cargo and crew to the Tiangong station and is due to take its maiden flight next year. Galactic Energy also plans to static fire and then launch its Pallas 1 vehicle before the end of this year. But before that, the company's been preparing its Series 2 rocket for its maiden launch. This launcher was initially planned to debut in June and is now expected to take flight in the next few weeks. A series of launch sequence rehearsals has recently been completed using a vehicle mock-up on the transport erector at Zhochuan. The solid and liquid engines have been hot-fired, and the fairings have now undergone load testing and separation trials to verify their mechanisms and structural integrity. Like the Series 1, this larger 3-stage vehicle uses solid motors and a liquid upper stage and can also be launched from either land or sea. Galactic Energy has become China's most successful private launch company to date, launching the Series 1 20 times so far, placing 87 satellites into orbit in the process. The company also plans to launch the world's first electromagnetic rocket launch pad by 2028, as we reported in a recent episode. Reports suggest the payload cost to orbit on the Series 2 will be roughly half of that of its predecessor, with the payload capacity of about 1.6 tons to a 500-kilometer low Earth orbit. 8 payloads are due to be carried on board its maiden flight, including the ultra-flat Lilac-3 test satellites, which will be used to validate attitude control and study how thin spacecraft interact with atmospheric drag. This week, Blue Origin announced its own proposal for a Mars telecommunications orbiter. But wait, didn't Rocket Lab just announce its own last month? What's going on? Well, there's no coincidence that both companies announced this. Early last month, the US Congress passed the so-called Big Beautiful Reconciliation Bill. Within it, the bill had language allocating $700 million towards the development of a Mars telecommunications orbiter. In other words, a satellite in orbit around Mars that could serve as a relay for communications between Earth and the different robotic missions on the Red Planet, and, well, maybe in the future, with humans on Mars. NASA currently relies on a series of aging probes orbiting Mars to communicate with its Martian assets, some of them even as old as the Mars Odyssey spacecraft, which was launched in 2001. None of these probes around Mars were made specifically to serve as a relay, though, so over the past couple of decades, there have been multiple proposals to send at least one orbiter around Mars that could relieve them from such a duty. So, the language in that reconciliation bill is not entirely new, but it's also quite lucrative for whatever company ends up getting the deal. I mean, $700 million is definitely nothing to sneeze at. So it's not a coincidence that Rocket Lab and Blue Origin have both decided to propose their own versions of the Mars Telecommunications Orbiter. It's also not a coincidence that both companies suddenly had a design for such an orbiter. In 2023, following delays and potential cost overruns for the Mars sample return mission, NASA decided to pause all work on it and refocus it, asking commercial companies and academia to come up with ways to perform the mission cheaper and faster than were planned at the time. In June of 2024, following a several months process of discussions and various information gathering meetings, NASA announced that it had moved forward with studies from several companies and organizations. These included, to no one's surprise, many of the major players in the US space industry, such as Rocket Lab, Blue Origin, Lockheed Martin, Northrop Grumman, and SpaceX. The whole reason why Rocket Lab and Blue Origin have now come out with a proposal for a Mars telecommunications orbiter in recent weeks is because they already had that included in their Mars sample return proposals in some form or another. In the case of Rocket Lab, the company was going to make use of its experience building the pair of Escapade satellites for NASA. Blue Origin's proposal makes use of its Blue Ring spacecraft, a sort of blend between a space tug and a satellite which could deploy ultra-high frequency satellites in a lower orbit while positioning itself in a higher orbit around Mars. But this communications orbiter contract wouldn't just be lucrative for those companies. With the increased focus on Mars with the new US presidential administration, these companies could also potentially get a foot in the door to have future access to a plethora of multi-billion-dollar contracts in support of a human spaceflight campaign to Mars. I mean, just look at Blue Origin. They've talked for years about going to the moon and supporting moon missions, and rarely talked about Mars. But now, well, they've got a whole design for a Mars telecommunications orbiter. On top of that, a few months ago, we had John Coloris, Blue's vice president of lunar permanence, saying that their future cislunar transporter could be used to send up to 30 metric tons to Mars. Almost as if Blue had already looked into using it for Mars missions. So there is a non-zero chance that in the coming years, there will be a heated race between commercial companies to support Mars missions. It's even possible that whenever SpaceX's Starship finally starts landing on Mars, it won't be the only commercial mission out there on the Red Planet. Well, there's been a bunch of space news from the United States this week, so let's run through some of it. It's another week, which means another new space policy proposal. Last week, it was to put a nuclear reactor on the moon's south pole, and this week, it's about streamlining licensing for launch and re-entry. U.S. President Donald Trump signed an executive order this week directing several agencies and offices, mainly the Department of Transportation, to carry out a series of actions that would streamline the launch and re-entry licensing process. Among the actions would be to, quote, eliminate or expedite the Department of Transportation's environmental reviews for, and other obstacles to the granting of, launch and re-entry licenses and permits. This action also includes a directive to the Department of Transportation to establish exclusions under the National Environmental Policy Act of 1969. That is, to create a list of things that would not need an environmental review going forward. The order also directs the Secretary of Defense, the Secretary of Transportation, and the NASA Administrator to eliminate review processes that are duplicative between state and federal agencies. Now, this is not the first time that a Trump administration has tried to streamline and expedite launch and re-entry licensing. Back in 2018, President Trump signed Space Policy Directive 2, which was directly aimed at streamlining regulations for commercial space. This resulted in the Part 450 licensing process that many companies have now gone through, but the problem is that all of them have complained about it. In some way, shape, or form, that attempt at streamlining regulations just didn't work. Yes, a lot of paperwork was cut by concentrating everything into one single licensing framework rather than multiple at once, but it also meant that if companies wanted to change their launch plans, they had to go through the licensing process once again, slowing everything down. This even became a bipartisan issue last year when Congress decided to establish a committee to look at ways to modify Part 450 regulations so that it wouldn't hinder space companies. Now, this executive order directs the Secretary of Transportation to, quote, reevaluate, amend, or rescind the regulations at Part 450 of Title 14, Code of Federal Regulations. So this order may actually undo what was done back in Trump's first administration. I guess only time will tell whether this new attempt at streamlining operations will succeed or not, and what may be some of the consequences. NASA is continuing to prepare for Artemis II, the first human spaceflight to the moon in more than 50 years. On August 10th, teams at NASA's Exploration Ground Systems transported the Artemis II Orion spacecraft from the Multi-Payload Processing Facility to the Launch Abort System facility. This follows an extensive campaign to load all of the fluids that Orion will use during its mission, including the propellant used by its European service module and the consumables used by its life support system. This also provided a unique opportunity for the crew of Artemis II, Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen, to don their launch and entry suits and go into the actual capsule that they'll be riding on the mission, as opposed to just being inside of a mock-up. With Orion now at the Launch Abort System facility, the spacecraft will be fitted with its Launch Abort System in preparation for flight. I guess the name of the building already kind of tells you what that's for. Once all that work is complete, Orion will then head out to the vehicle assembly building for stacking with the SLS rocket that will carry it to space. And if all goes well, that could happen in less than 2 months from now. And if schedules hold, we may see Artemis II launching about 4 months later, meaning we may be now less than 6 months away from seeing humans once again flying around the moon. I don't know about you, but I am super excited for it. Relativity, Space, and Stoke are both slowly but steadily getting closer to the first launch of their Terran R and Nova rockets, respectively. This week, Relativity released even more information as part of their monthly development updates for Terran R. The company is starting to build flight hardware with 92% of the engine components for the first flight now completed. The first stage engine, the Eon R, has also completed qualification testing, and the company is now moving into testing of the vacuum-optimized version of this engine, which they call Eon V. At Launch Complex 16, teams continue to build the massive hangar that will be used for integration of Terran R before launch, and construction has started on the launch pad's water tower. Stoke, on the other hand, is also similarly progressing through its own steps to get Nova to the launch pad. Just a few days ago, the company posted pictures on social media showing some of that progress. This, for example, shows a new version of Stoke's Zenith engine, the engine that will power Nova's first stage. The engine has been developed in pretty much a record time given its complex burn cycle, and Stoke is focused on improving it now that early development is complete. The company also shared a picture of the base heat shield of its Andromeda engine, the engine of Nova's second stage, as well as a picture of a Nova Stage 2 being installed at its structural test stand. At Stoke's Launch Complex 14, teams have also begun the construction of the Lightning Protection System towers, as well as progressed with the construction and outfitting of the launch mount and umbilical tower. tower. We've kept a close eye on both Stoke and Relativity, not just via the internet, but also from the air, thanks to our Space Coast flyovers. We recently released a video with the latest on what's going on at the Space Coast, so check that out for some additional shots and information. It may not be long until we see both Nova and Terran R in future flyovers. Late on Thursday, Blue Origin announced that they're targeting September 29th for the launch of their next New Glenn rocket. The mission will be carrying NASA's Escapade mission, and according to the company, they've been working closely with NASA on the timeline for that second flight of New Glenn. Blue also teased some upcoming activity, stating that we'll start seeing some, quote, exciting things happening at the pad down in Florida very soon. Well, Blue, what we could see during our latest Space Coast flyover was that you're currently busy with some New Glenn aft module testing, and that you also had the New Glenn simulator out on the pad. So what will be the next steps towards Flight 2? The first time around, it took quite a while for Blue to go from aft module testing to actually flying the rocket, so they really must think that they can shrink those timelines this time. Astronomers using the James Webb Space Telescope's mid-infrared instrument may have found, and then lost, what could be the closest exoplanet ever directly imaged around a sun-like star. In August of last year, Webb detected a faint object designated S1 orbiting the nearby star Alpha Centauri A, which is just over 4 light-years away. The potential planet may be a Saturn-sized gas giant, and it lies inside the star's habitable zone, around 2 astronomical units away from it. That's roughly twice the distance between the Earth and the Sun. However, when scientists looked again earlier this year, the planet was nowhere to be seen, possibly because it's now hidden within the star's glare as it moves along its orbital path. Researchers plan to conduct more observations to confirm whether S1 is real or simply a fleeting data artifact. They'll need to wait until this time next year, however, based on orbital modeling that predicts that S1 is following a 2 to 3 year orbit. Alpha Centauri A is the third brightest star in our sky and is one of a binary pair of stars together with Alpha Centauri B, both of which are similar to our Sun. Together with the faint red dwarf Proxima Centauri, they form the Alpha Centauri star system in our southern sky. Astronomers have confirmed 3 worlds orbiting Proxima Centauri and have long searched for possible planets around the other 2 stars. But why has this potential discovery excited science fiction fans as well as scientists? Well, in James Cameron's Avatar movies, the habitable moon Pandora orbits a gas giant named Polyphemus, which itself is orbiting, you guessed it, the star Alpha Centauri A. S1 could yet be a real-world counterpart to Cameron's fictional world, and proof that such systems might exist even closer than we'd imagined. In astronomical terms, this is right next door in our own stellar backyard. That said, since it's a gas giant, the planet wouldn't support life as we know it, and for now, it does remain elusive. But if it does reappear, it could be a striking case of life imitating art. Elsewhere in deep space, the European Space Agency's Hera spacecraft has captured its first in-space asteroid images, but not of its intended targets. You might recall NASA's Double Asteroid Redirection Test, or DART mission, which deliberately impacted the moonlet Dimorphos in 2022. Hera was launched 2 years later aboard a Falcon 9 to take a closer look at the aftermath of that test. Hera will measure the impact crater's size and quantify how much momentum was transferred by DART's impact. It'll also probe the mass, shape, internal structure, and surface properties of both Dimorphos and its binary partner, Didymos. Now, Hera won't arrive at Didymos until late next year, but while en route to the binary asteroid system, it took the opportunity to prove that it can lock its cameras onto faint targets in the vastness of space. As it traveled, onboard software and cameras successfully tracked asteroid 1126 Otero, which was around 2.8 million kilometers away. Hera successfully photographed the asteroid over a period of 3 hours, and in late July, imaged an even dimmer target. Asteroid 18805 Kelly Day was over twice the distance away and 40 times fainter than Otero. Hera also carries 2 CubeSats on board. Melania and Juventus will investigate surface and subsurface composition and the local gravity field through radar. These observations will give us a better insight into kinetic impactor methods that could one day help us to deflect a potentially dangerous asteroid. You can read more about this mission in our news article at NASASpaceflight.com. Meanwhile, in a galactic drama far deeper into space, NASA's Hubble and Chandra observatories have discovered a potential example of a rare class of black hole snacking on a star. NGC 6099 HLX-1 sits on the fringes of a distant elliptical galaxy some 450 million light-years away in the constellation Hercules, as seen here in purple. These intermediate mass black holes, as they're known, are between a few hundred to a few 100,000 times the mass of our sun. Astronomers hope that observing this mid-sized black hole in the act could help solve a cosmic mystery, showing how black holes grow from the small ones left behind by dead stars into the giant versions that sit at the hearts of galaxies. Elsewhere, NASA's Imaging X-ray Polarimetry Explorer, or IXP spacecraft, made a remarkable find with another black hole that pulses in brightness like a cosmic heartbeat. The spacecraft measured the polarization, the way light waves are oriented, in the X-rays emitted from this flickering source and found them to be far higher than expected. This matters because polarization tells astronomers about the direction and strength of magnetic fields and how light is scattered near the black hole. The finding suggests the hot swirling plasma that surrounds a black hole, known as the corona, may be behaving very differently than current models predict. It's forcing astronomers to revisit long-standing theories about how matter interacts with intense magnetic fields just outside the event horizon. This black hole's heartbeat could reveal a lot more about how these extreme cosmic engines really work. This is your weekly space traffic report provided by Next Spaceflight. We kicked off the week with the return of Crew 10, SpaceX's 10th crew rotation mission to the ISS. Crew Dragon Endurance and its crew of 4 undocked from the station's front docking port on August 8th at 22:15 UTC and was followed roughly 17 hours later by a splashdown off the coast of San Diego. On board Endurance were Commander and NASA astronaut Anne McClain, pilot and NASA astronaut Nicole Ayers, mission specialist and JAXA astronaut Takuya Onishi, and mission specialist and Roscosmos cosmonaut Kirill Peskov. With this mission, the crew now adds 147 days of time spent in space to their respective careers. This return also makes room on the ISS for the arrival of the CRS-33 mission later this month, which will feature an upgraded Dragon trunk with extra propellant tanks and Draco thrusters for reboosting the station. Back on the ground, we had our first launch of the week, the second batch of Kuiper satellites launching on SpaceX's Falcon 9 rocket. The flight had been plagued with vehicle and weather-related delays, but it finally took off this past Monday. The interesting thing about this launch, though, was the booster, which was new for this flight. This was booster B1091, and it's not actually a Falcon 9 booster, but rather a Falcon Heavy center core just dressed as a Falcon 9 booster. Instead of having the Falcon Heavy interstage and connections for the side boosters, it has a regular Falcon 9 interstage and no side booster connections. Falcon Heavy center cores are built with thicker tank walls and reinforcements, so you can't really fly a Falcon Heavy with a regular Falcon 9 booster as its center core, but you can do the opposite. And that's exactly what SpaceX did on this mission. This way, they can get more uses out of it before it actually flies as a Falcon Heavy center core in whatever future mission that it's supposed to fly on. This week, we also had the third flights of Ariane 6 and of Vulcan. Ariane 6 carried the METOP SGA-1 weather observation satellite into orbit for the European Space Agency and EUMETSAT. As for Vulcan, it carried out the USSF-106 mission for the US Space Force. This marked the first launch of Vulcan for the US Department of Defense after having been certified to fly on the department's national security space launch missions earlier this year. After so many delays, ULA will now have to demonstrate that they can hit a decent launch cadence to deliver on the many launch contracts that they have in their backlog. And this past week, we also had another 2 Starlink launches from the United States and 1 Guoang launch from China, which made use of the country's most powerful rocket in its inventory, the Chang Zheng 5B. Chinese company Landspace also launched the third flight of its Zhuche 2E rocket this Friday. Unfortunately, it doesn't seem like this was a fully successful launch, at least according to unconfirmed reports on Chinese social media indicating a malfunction during second stage flight. Going into next week, we expect a launch of a Soyuz 2.1A rocket from the Baikonur Cosmodrome, carrying the Bion-M No. 2 spacecraft. What's interesting about this launch is that the Bion-M spacecraft are based on the Vostok spacecraft that flew way back during the early days of human spaceflight in the early 1960s. Aside from their use with humans on board, back in the day they would also use these to fly film cameras that would then be recovered and analyzed afterwards for reconnaissance. Of course, now with digital cameras, this is no longer needed, but they're still being used to carry certain experiments into orbit that they can then recover afterwards for inspection. You know the saying, if it ain't broke, don't fix it? Well, in this case, they've been carrying that out now for over 60 years, hence why they're still using a modernized version of the Vostok capsule. From the United States, we also expect a couple of Starlink Starlink launches from Vandenberg, both of which will be heading southwest. So if you're in Southern California, you may be able to see them, but be mindful that this isn't the kind that hugs the coast, and they will be going away from you. These will also happen a few hours after sunrise, so the viewing conditions may not be perfect. Also next week, we'll have the USS F-36 mission from Florida. This will be the 8th launch of the secretive X-37B space plane from the US Space Force, and it'll be the 3rd time it's launched on a SpaceX rocket. The first time it was on a Falcon 9 back in September 2017, and the second was just a few years ago in December 2023 on board a Falcon Heavy, which sent the spaceplane out into a highly elliptical orbit. This mission will see the first stage booster attempting a landing back on Landing Zone 2. You may recall that SpaceX recently retired Landing Zone 1. So with this return to land, it also means we should expect sonic booms across the eastern coast of Central Florida. Next week, we may also potentially have an Electron launch from New Zealand, but that's yet to be confirmed by Rocket Lab as of recording, though notices have started to be published. Once that's confirmed, I'm sure our next spaceflight teams will add it to our database. So if you want to stay up to date about that and any more upcoming launches and events, be sure to download the Next Spaceflight app on your phone or visit the website at nextspaceflight.com. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and we'll see you all again next week to recap this week in spaceflight.